A few thoughts surrounding the issues of energy storage in an attempt to understand the potential challenges that may be encountered. The management of recovered energy requires a robust, versatile energy storage system. The methods used as a buffer, to provide a delay between the accumulation of stored energy that may be consumed on demand at a later time, is a fundamental issue. The use of a short-cycle regeneration strategy may reduce the needs, or mitigate the total requirements, for large-size storage systems. The basic premise for the need of energy storage is to act as a buffer between the unpredictable or intermittent generation of incoming energy in the charging stage, and the desired consistent discharge of energy. The range of the buffer may be determined by the gap in time between the total incoming volume of energy and the desired output flow rate. An ideal storage buffer maintains sufficient reserve capacity both on the charging and discharging sides to maintain consistent power output, to operate around the clock, 24/7 all year long. The size of the energy storage capacity may be established by the duration or desired reserves of output for the time period selected. The major limiting factors in establishing an energy storage system are largely determined by the acceptable capital cost of the system itself, and the energy conversion losses inherent in the storage method chosen. The three main steps in the energy storage cycle are the charge cycle, storage stage, and discharge cycle. By disassociating the charging cycle from the discharging cycle, a storage technology may achieve the function of a time-shiftable energy storage system. The implementation of the flexibility to simultaneously charge and discharge the storage system may maintain a consistent, reliable and stable buffer. The common sources of energy used to charge an energy storage system tend to be unpredictable or intermittent types of generation. An ideal energy storage system is designed to accommodate the fluctuating flow of incoming power. Energy may be collected from numerous harvesting methods and sources to charge the storage system. Energy, if it is not to be consumed right away, can be accumulated and retained in storage mediums for future usage. The two basic approaches to energy storage are in the form of either electric charge storage or in the form of a non-electric charge alternative potential energy storage medium. The traditional electric charge storage thinking surrounds the storage of surplus electricity in the form of battery storage and electrochemical batteries and has expanded to include capacitors and flow batteries. Energy may be collected, consolidated and stored in various alternative storage medium forms. Energy storage in the forms of temperature or pressure are broadly understood as working fluids, both pressurized non-compressible liquids and compressed gases. Other lesser-known forms of alternative or potential energy are an important factor in the energy recovery, harvesting and storage field. Potential energy storage in the form of materials classed as mass lends itself to short-cycle regeneration. Depending on the storage methodology, losses of energy in the duration of storage may occur due to self-discharging rates. The conversion rate from the storage medium, back into usable energy, must be taken into account to properly allow for the losses incurred overall into the charging, storage and discharging efficiency. Maintaining a reliable stable discharge rate of the accumulated stored energy, as desired or on demand, is a fundamental goal of an energy storage technology. The speed of response when called upon to discharge is an important factor to take into account. The conversion losses of the discharge methods may or may not be a critical factor. A controlled discharge rate may maintain the energy requirements to keep an industrial plant operation supplied with a continuous baseline power input. A properly designed storage system may be compatible with a short-cycle regeneration strategy. The energy storage accumulator acts as a buffer between the highly variable incoming charge rates and a homogeneous discharge output. Alternative and harvested energy sources are not only intermittent from day to night, they may vary widely from minute to minute in intensity. This continuous fluctuation is contrary to the homogeneous output required to reliably feed the electricity grid. The storage accumulator may accept incoming charges at various intensities and intermittent rates, and act independently of the discharge cycle. The most desirable forms of energy storage buffers may be able to charge and discharge simultaneously. The size and scope of the storage capacity will determine the degree of independence the system may achieve or maintain. In summary, Energy storage may take the form of either electron storage or non-electron storage and allows us the ability to capture energy at one time, for use at a later time when it is needed. Additional videos about energy and energy management are available, and links have been provided in the comments. You may also check out our website Recovery 2.0 at www.waste.net.